Hi, this is Sarah LaSelva, and I'm the Product Marketing Manager for our SDR portfolio. Today I'm going to give you a quick introduction to what is a USRP. NI's USRPs are what we call software-defined radios, and this slide shows the typical architecture for an SDR. So starting on the left side, a typical SDR is made up of two different types of processors. We have a CPU as well as an FPGA. Now, for our SDR portfolio, sometimes the CPU is embedded in the actual device itself, but most of the time the CPU is something that we connect to externally using, for example, gigabit Ethernet, 10 gigabit Ethernet, PCIe, or USB. The CPU is generally used where we do our control and set control of the device and what we want to do with it, and we can also process data that we get back from the device. The FPGA is where we would do anything that you really need real-time processing capabilities or handling things like streaming. And next up, after the FPGA, we are connected up to some baseband converters. So we have digital to analog and analog to digital. Now, if you just look at this part of the block diagram, it actually should feel familiar because it's more or less the same as a data acquisition board. The combination of some sort of processing as well as D to A's and A to D's. What makes SDRs different from a DAC board is what comes next on the right, and that is an RF front end. The RF front end on an SDR is general purpose and is typically tunable between a wide different range of frequencies. It can have a single LO or it can have multiple LOs. Sometimes it'll have amplifiers and varying different levels of filters depending on the model of SDR that you're looking at. SDRs can be used in a wide variety of different applications. They can be used in everything from doing radar prototyping and target emulation, all the way up to doing joint communications and sensing and AI research for wireless. Now, there's typically two main different areas where we see SDRs used. We have it for doing communications related research, specifically like wireless comms, as well as on more aerospace and defense type of applications. And what we're seeing now with 6G is there's actually kind of a convergence where some of these applications apply to both. So, for example, non-terrestrial networks or using satellites for communication is a traditional aerospace and defense application, but we're seeing a desire to use satellites for commercial communications and commercial wireless that connects up to your cell phone within 6G. So that's just one example of where these are emerging. But SDRs are very flexible and can serve a wide variety of the applications, including some that aren't shown on this screen. At NI, we have a wide breadth and depth within our portfolio for doing prototyping and deployment. We start with host-based, low size, weight, and power devices. We have devices with FPGAs. With our VST portfolio, we have high frequency, wide bandwidth, and instrument-grade RF. We have deployable, and we also have standalone USRPs where we have the FPGA with an embedded processor, so you don't have to connect up to a host computer. NI has the widest breadth and depth of SDR portfolio of any company on the market. And what makes our product family so valuable is the combination of hardware and software. So, as I mentioned, we have SDRs ranging from low cost to higher end, and we serve a wide variety from single channel all the way for devices that can be connected up together to build MIMO systems. On the software side, our UHD driver is free and open source, and it works with a variety of different software programming languages, including GNU Radio, Python, and various toolboxes from the MathWorks. In addition to working with popular open source software, we also have software that was developed by our team called RF-NOC, or RF Network on Chip, that's meant to abstract away the difficulties of programming the FPGA. We know that not everyone knows how to program using Verilog and HDL coding, and it can be very challenging. And so RF-NOC is a tool that's meant to make this easier and more approachable for the average user. And finally, we have LabVIEW support for the majority of our portfolio. This slide shows just an overall high-level spreadsheet of our USRP catalog. So as I mentioned in previous slides, we have the low swap size, weight, and power starting on the left-hand side of the slide, ranging up to our higher end USRP on the right. And we have a wide variety of options in between. So this will give you kind of a cheat sheet to show the different frequency ranges that are supported, as well as the different bandwidth, channel count, synchronization options, as well as software support for our portfolio. And finally, to give you just one more little cheat sheet to try and make it easy, we know that we have multiple different branded versions of some of these products, especially the older products in our portfolio, and it can be confusing to figure out what software is supported as well. So on this last slide, just wanted to give an overview of the different software options that map back to the different hardware options. So hopefully this was a good introduction, and if you have any questions, feel free to reach out. Thanks.